Hi everyone, welcome to another linear algebra tutorial. In this tutorial, we will be learning how to determine if a vector is in the span of a set of vectors. We will be given certain examples here. The question can actually ask us, is the given vector in the set generated by the given set? Which means that we want to know whether the vector falls in the span of those set of vectors. Let's begin with two examples over here. Let's begin the first example. We have four examples here to begin with, so that we can know whether a vector is in the span of a set of vectors. For the first example is this. So our given vector is on the left hand side here, 2, 3, whereas this will be the span of a set of vectors, 1, 4 and 1, 5. Hence, we can express the span of vectors in this form. xy equals to a 1, 4 plus b 1 over 5, where a and b are real values, and we will want to find the scalar values of those two variables. We can expand it, so x equals to a plus b and y equals to 4a plus 5b. So we are given this vector, we just plug it in into x and y. So x and y is 2, 3. So after you expand, a plus b equals to 2 and 4a plus 5b equals to 3. Now the first step is to abbreviate this linear system with this matrix over here. And after this, you want to eliminate the a variables on the second row. Hence, we add minus 4 times for row 1 to row 2. The working is over here. For left hand side, you get b, and right hand side, you get minus 5. Hence, you get this matrix in echelon form. And from the second row, we can see that b equals to minus 5. And you plug into your first row, which is a plus b equals to 2. Therefore, a is equals to 7. Since the values of a and b are consistent in both rows, we can conclude that the given vector is in the span of vectors. For now, let's go to the second example, which is this. So our given vector is here, and our span of set of vectors are here. So the span of vectors is given as this. X, y, z equals to a to 1, 0 plus b 1, 0, 1. Expanding it will give us in this form. And now we are given this vector. So we just plug it in. And we do a system of linear equation from here. Hence, you get this. And now again, the same step. We abbreviate this linear system with this matrix. So you get this matrix here. So as you notice, row 1 has a higher coefficient of a than row 2. So what do? We swap row 1 with row 2 to get this equation here. And now, since that both rows have the a variables, we want to eliminate the a variable on the second row. Hence, we add 2 times of row 1 to row 2. And the working is shown here. Hence, you get this matrix. And after that, you add minus 1 times of row 2 to row 3. Why? You want to eliminate the b variable. The working is shown over here. And after that, you got it in the echelon form. But look carefully. You notice that from the third row, okay, the equation of 0 equals to 2. This 0 equals to 2 is inconsistent and is wrong. Therefore, the system has no solution. No solution of A and B. Therefore, the given vector is not in the span of vectors. And now, let's go through the second last example. Again, you're given this vector, and these are the span of vectors. So now, we express the span of vectors in this form again, with 4 perimeters here. And we expand it in this form again. Hence, we plug in our given vector again. And we make a system of linear equations from here. So this is our system of linear equations again. And the first step, we can abbreviate this linear system with this matrix. So you notice that row 2 has no coefficient of A. Hence, we swap row 2 with row 3 and we get this matrix. So now you want to eliminate the A variable on the second row. Hence, we add minus 4 times of row 1 to row 2. Hence, the working can be shown here for left hand side. For left hand side, you get minus 3b, minus 12c, minus 15d. For right hand side, you get minus 4. Hence, you get in this form. And the same thing, you notice that row 2 has a higher coefficient of b than row 3. Hence, we swap row 2 with row 3. Hence, you get in this form. So the same thing, you have to eliminate the b variable on the third row. Hence, we add 3 times of row 2 to row 3. Hence, you get this form. But look carefully. You notice that d is not a leading variable in this system. However, we want to know whether the vector falls in the span of the set of vectors. In other words, exists in the set of vectors provided. Therefore, it has at least a non-leading variable. Therefore, it has infinitely many solutions of A, B, C, and D. Therefore, the vector will still exist in the span of vectors, even though it has many solutions. So now, let's take a look at the last example. Which is this. So this is our span of vectors given. And again, we expand our span of vectors first to this form. After that, we plug in our given vector for this one. We plug in and we got this. So we make a system of linear equations. We get in this form. However, you notice that there is this inconsistent equation 0 equals to 1. Hence, from the third row, you can see that this is inconsistent. This means that the linear system has no solutions of A and B. Therefore, the given vector is not in the span of vectors. We shall now call it a day for our linear algebra tutorial. Feel free to ask me if you have any queries, and I will reply to your queries immediately. Thank you for watching the linear algebra tutorial.